When wiring a detached garage for a 100 amp subpanel, the choice between aluminum and copper conductors is significant, particularly considering cost and performance. Aluminum has become an increasingly attractive alternative to copper due to its lower price, but it's essential to understand the implications of each material before making a decision. Let's delve into the considerations for using aluminum versus copper for this specific application. Firstly, ampacity and conductor sizing must comply with the National Electrical Code or NEC. For a 100 amp subpanel, you need to ensure that the conductors are appropriately sized to handle the load safely. According to NEC Table 310.15, V16, which is now NEC Table 310.16 in newer editions, the ampacity of conductors is determined based on insulation type and temperature rating. For copper conductors with THHN or THWN insulation, which are commonly used in conduit, the size of number 4 American wire gauge or AUG may be sufficient for 100 amps, provided the termination temperature is suitable. Aluminum conductors, on the other hand, have a lower ampacity than copper for the same gauge size. Therefore, for a 100 amp service, you would typically need a larger gauge aluminum conductor to achieve the same ampacity as a smaller copper conductor. For example, a number 2 AWG aluminum conductor with XHHW insulation might be required. Secondly, cost is a major factor, as highlighted in the question. Aluminum is generally less expensive than copper, sometimes significantly so. The price difference can make aluminum an attractive option, especially for longer runs like the 43 feet distance mentioned for the detached garage. However, it's essential to consider the total installed cost, which includes not only the conductor price but also the cost of connectors, conduit, and labor. Aluminum requires specific connectors and installation practices to prevent oxidation and ensure a reliable connection. Thirdly, conductivity is another important consideration. Copper has higher conductivity than aluminum, meaning it can carry more current for a given size. This difference in conductivity is why aluminum conductors need to be larger than copper conductors for the same ampacity. While aluminum conductors are perfectly safe when properly sized and installed, the larger size can sometimes make them more difficult to work with, especially in tight spaces. Fourthly, expansion and contraction differences exist between aluminum and copper. Aluminum has a higher coefficient of thermal expansion than copper, meaning it expands and contracts more with temperature changes. This difference can affect the tightness of connections over time, potentially leading to loose connections and overheating. To mitigate this risk, it's crucial to use connectors specifically designed for aluminum conductors and to follow proper torquing procedures during installation. Antioxidant compounds are also recommended to prevent oxidation at the connection points. Fifthly, corrosion is another factor to consider. Aluminum is more susceptible to corrosion than copper, especially in damp or corrosive environment. When aluminum corrodes, it forms a non-conductive oxide layer that can increase resistance and generate heat. To prevent corrosion, it's essential to use corrosion-resistant connectors and to protect the aluminum conductors from moisture and chemicals. Sixthly, installation practices for aluminum and copper conductors differ. Aluminum conductors require careful handling to avoid damage. They are more prone to nicking and scratching than copper conductors, which can weaken the conductor and increase the risk of failure. When pulling aluminum conductors through conduit, it's essential to use appropriate pulling lubricants and to avoid excessive pulling force. Furthermore, aluminum conductors require the use of antioxidant compounds at all connections to prevent oxidation. Seventh, termination temperature ratings are important to know. The termination temperature rating of the equipment, such as circuit breakers and panel boards, must be considered when selecting conductor sizes. The NEC requires that conductors be sized based on the lowest temperature rating of any connected termination. If the equipment is only rated for 60 degrees Celsius, then the conductor ampacity must be based on the 60 degrees Celsius column in NEC Table 310.16. This may require using a larger conductor size than would otherwise be necessary. 8. Conduit fill is also a factor to address. The NEC limits the number of conductors that can be installed in a conduit based on the conduit size and the conductor size. Because aluminum conductors are typically larger than copper conductors for the same ampacity, they may require a larger conduit size. This can increase the cost of the installation and make it more difficult to work with, especially in tight spaces. Ninth, weight is another consideration. Aluminum conductors are lighter than copper conductors for the same ampacity. This can make them easier to handle and install, especially for long runs. However, the larger size of aluminum conductors can offset some of the weight savings. 10th, compatibility with existing wiring must be considered. If the existing wiring in the house is copper, it's generally recommended to use copper conductors for the new subpanel as well. This avoids the need for special connectors and installation practices to join aluminum and copper conductors. However, if the existing wiring is aluminum, then it may be more cost-effective to use aluminum conductors for the new subpanel. 11th, future expansion should be taken into account. If there is a possibility of adding more circuits to the subpanel in the future, it may be wise to install a larger conduit and conductor size than is currently required. This will make it easier to add new circuits later without having to replace the existing wiring. 12th, local codes and regulations should be followed. Local codes and regulations may have specific requirements for the use of aluminum conductors. It's essential to check with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. 13th, insurance requirements might also apply. Some insurance companies may have specific requirements for the use of aluminum conductors. It's essential to check with the insurance company to ensure that the installation meets their requirements. 14th, long-term reliability is an important factor. Both aluminum and copper conductors are reliable when properly installed and maintained. However, aluminum conductors are more susceptible to corrosion and loosening of connections over time. Therefore, it's essential to use proper installation techniques and to perform regular maintenance to ensure long-term reliability. 15th, voltage drop should be accounted for. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Aluminum conductors have a higher resistance than copper conductors, so they will experience a greater voltage drop for the same length and current. To compensate for this, it may be necessary to use a larger aluminum conductor size than would otherwise be required. 16th, tools and equipment are needed. Installing aluminum conductors requires the use of specific tools and equipment, such as a torque wrench and antioxidant compound. These tools and equipment may not be readily available, which can increase the cost of the installation. 17th, inspection requirements will apply. Electrical inspections are typically required for new installations and modifications to existing electrical systems. The electrical inspector will verify that the installation complies with all applicable codes and regulations. It's essential to be prepared for the inspection and to have all necessary documentation available. 18th, safety is paramount. Electrical work can be dangerous, so it's essential to take all necessary safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and energizing circuits before working on them. 19th, professional advice is available. If you are not comfortable performing electrical work yourself, it's best to hire a qualified electrician. A qualified electrician will have the knowledge and experience to safely and correctly install the subpanel. 20th, documentation is key. Keep accurate records of all electrical work performed, including the conductor sizes, conduit sizes, and torque values. This documentation will be helpful for future maintenance and troubleshooting. In summary, while aluminum conductors offer a cost advantage, it's crucial to carefully consider all factors, including ampacity, conductivity, expansion and contraction, corrosion, installation practices, and code compliance before making a decision. Copper remains a reliable and widely used option, particularly for shorter runs and situations where ease of installation and long-term reliability are paramount. Always consult with a qualified electrician and adhere to local codes and regulations to ensure a safe and compliant installation. The NEC guidelines are the baseline, but local codes can be more restrictive. Also, the type of load that the subpanel will serve should also be considered. If the load is sensitive to voltage fluctuations, copper might be the better choice due to its low voltage drop. Finally, consider the environmental conditions. In corrosive environments, copper might be a better choice due to its resistance to corrosion. By carefully considering these factors, you can make an informed decision about whether to use aluminum or copper conductors for your detached garage subpanel.